Hey guys, welcome back to this video. Now we're going to solve this problem, two sum. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. This is the constraint. Now let's see some examples. If you are given nums equals to this array and target equals to 9, you have to find two elements in that array that add up to the target 9. For this input, we see that 2 plus 7 is 9. So these two elements add up to 9. And we have to return the indices of these two elements. And the indices of this two element is 0, 1. So we have to return this array of indices of the two elements that add up to target. So for this input, we have to return this output. Now how we can solve this problem? We can solve this problem using nested for loop pretty easily. The I will point to the first element for first iteration of this outer loop, and for the inner loop it will start from here. It will move from here to the rightmost element, and this I will move to this element. Alright, and here we will check every single pairs. First we will check this pair. Does the sum of these two pairs is 9? Yes, it is. And also we will check all possible pairs. Okay, then we will check for this pair, and also for this pair. For the worst case scenario, the solution will take bigger of n squared time complexity, and this is not an optimized solution. So this solution is not accepted in the coding interview. You have to optimize this solution. Is there any way around? We can optimize this solution using hash map. Now let's see how we can solve this problem in bigger of n time complexity using hash map. For sake of understanding, let's assume we're given this array and target equals to 9. And this is our hash map. We have key and value. As key, we will store the element, and as value, we will store the index. First thing, we'll iterate through this array from left to right, from this element to the rightmost element. For first iteration, we have this element 2. So our first element is 2. First thing, we're going to calculate the complement. Target minus the current element. So 9 minus 2 is 7. Does 7 exist in the hash map? No. Hash map is empty. So let's insert this value 2 to the hash map and the index as value and the element as key. Then for next iteration, we have this current element 7. Now let's calculate the complement. Target minus the current element. 9 minus 7 is 2. Does 2 exist in the hash map? Yes, 2 exists. So we will return the index for 2, and that is 0, and the index of our current element, and that is 1. So we will return this array. Now let's take another example for better understanding. In this time, we choose target equals to 26. And we have this hash map right over here. For first iteration, we have this element 2. Now let's calculate the complement. 26 minus 2 is 24. Does 24 exist in the hash map? No. So let's add 2 as key and the index 0 as value. Then for next iteration, we have this element 7. Now let's calculate the complement. 26 minus 7 equals to 19. Does 19 exist in the hash map? No. So let's add this element to hash map and the index as value. Then for next iteration, we have this element 11. Now let's calculate the complement. 26 minus 11 equals to 15. Does 15 exist in the hash map? No. So let's add 11 as key and the index 2 as value. Then for next iteration, we have this element 15. Now let's calculate complement. 26 minus 15 is 11. Does 11 exist in the hash map? Yes, 11 exists. So let's return the index for 11, and that is 2, and the index for current element, and that is 3. And we will return this array. of indices. And this is how we can solve this problem in big O of n time complexity, and it will also take big O of n space complexity for the hash map. For better time complexity, we can trade off our space complexity. Now let's see how we can implement the solution using pseudocode. Alright, this is our pseudocode implementation. We have this function TwoSum. It takes an array and target. Then we construct a hash map, new hash map. Then we're going to run a loop from left to right of this array. Then we're going to calculate complement, target minus the current element, and then we're going to check does complement exist in our hash map. If exists, then return the index from the hash map and the index of current element, return them as an array. If not, then insert the element and index to the hash map. If we found no TwoSum, then we'll throw an exception or we'll return false or null depending on the programming language. In this time, we choose this different target. Now let's see how we can find the solution using the pseudocode. So first we'll iterate through this array from left to right. First we have 2. Now first let's calculate the complement, and that is 7. We see 7 does not exist in the hash map. So let's insert 2 and as key 0. Then for next iteration we have 7. 13 minus 7 equals to 6. Does 6 exist in the hash table? No. So let's insert 7 as well. 7 and as value the index. Then for next iteration we have 11. So 13 minus 11 equals to 2. Does 2 exist in the hash map? Yes, it is. So let's return the index of 2. The index of our current element is 2. So we have to return this array. And this is how we can solve this problem. The solution will take big O of n time complexity, and it will take big O of n space complexity to construct the hash map. We can trade off our space complexity for better time complexity. Alright guys, this is my solution to this video. If you have any problem understanding this solution, let us know. Thanks for watching. I'll see you in the next video.